This is pretty remarkable. AI models are becoming faster, cheaper, and more open at an incredible pace. DeepSeek Flash is a great example of what lightweight systems can already do. But now we're seeing open frontier models seriously challenge companies like OpenAI and Anthropic. One of the most interesting examples is Qwen 3.8 Max. Depending on how you use it, the cost can be around 5 to 10 times lower than comparable frontier models, while still delivering an impressive level of performance. And this isn't simply another text-only AI. Qwen 3.8 Max can work across different types of information, with vision and audio capabilities, as well as a 1 million token context window, But what really stands out to me is its ability to handle agentic workflows. You can give the model a complex objective and allow it to keep working independently while you focus on something else. That's a very different way of using AI. Instead of constantly prompting a chatbot, you're essentially giving yourself a digital worker that can continue making progress in the background. The amount of time it can operate independently makes this even more interesting. Many AI systems can work autonomously for a few minutes or perhaps several hours before they need human input. This system has demonstrated something much more extreme. Up to 16 days of autonomous work, Starting from an empty directory, it can write code, run tests, find problems, fix its implementation, and continue iterating. It has even been used to reproduce research papers and make meaningful improvements. That's a major shift in what we expect from AI agents. And the applications go well beyond research. These systems can build websites, develop applications, and handle complicated software tasks with surprisingly little supervision. When you combine those capabilities with relatively inexpensive API access, the economics become very interesting. If performance keeps improving while prices stay this low, other AI companies may eventually have to lower their own prices to compete. And there's another important piece. The team is committed to releasing the model weights, which could make Qwen even more valuable to the OpenAI community. The obvious limitation is the size of the full model. Most people simply won't have the hardware required to run it locally. That's why the smaller models in the ecosystem are just as important. Earlier, Qwen 3.6 models with 27 and 35 billion parameters have already built a strong reputation and remain extremely capable, even with newer frontier models arriving constantly. I'd compare these smaller models to the Toyota Corolla of AI ***. They aren't necessarily the biggest or most impressive systems, but they're practical, reliable, and much easier to access. And for the average user, having a powerful model that can actually run on available hardware is far more useful than owning something enormous that requires a data center. These smaller open models could become the everyday AI assistants that people use for almost everything. There's another reason I think Qwen is worth watching. Humanities last exam. AI benchmarks aren't perfect. Some can be optimized for, and others can produce misleading comparisons, so they need to be interpreted carefully. But Humanities last exam is interesting because it was designed around extremely difficult questions covering advanced academic knowledge. When the benchmark first appeared, some of the strongest closed AI systems, backed by enormous budgets, were scoring only around *2%**. Just over a year later, an open model has pushed beyond *50%**. That's an extraordinary improvement in a very short period of time. Benchmarks like this aren't the whole story, but they provide another useful signal for tracking how quickly AI capabilities are advancing. And this is what makes the current OpenAI ecosystem so exciting. New models and new capabilities are appearing constantly, giving researchers and developers access to technology that would have been extremely difficult or expensive to use just a few years ago. Powerful open models, lower costs, and increasingly autonomous agents are creating an ecosystem that would have seemed unrealistic not long ago. Of course, none of this works without computing power. That's why I use lambda to reproduce AI research papers, often within minutes. It's also useful for training models, fine-tuning existing ones, running inference, and experimenting with text to image and video systems. You can even run a DeepSeek chatbot or AI agent on powerful NVIDIA GPUs without having to build the infrastructure yourself. I can take an idea from a research paper, launch the experiment, and start getting results almost immediately. And that's exactly what makes this new era of OpenAI so exciting.